Hello, this is Dr. Patrick Hanley at Hanley Innovations. I'd like to show you how to use Stallion 3D to solve half geometries, such as the Onera M6 wing. However, in this particular video, we're going to concentrate on using Stallion 3D to solve a full geometry where we can take advantage of symmetry to either increase the resolution or have the same resolution run in half the time. Let's get started. So to solve half the geometry, what we have to do first, as usual, is to go to the design menu, import the STL file. Here we see our geometry. Next, we go to the size/scale option. And the important thing here is to set up the CFD boundaries based on the STL file. Next, we keep everything else default. Click OK. And then the next thing is to look at the geometry. To do that, we can click the visualization, view geometry only, and we can see that we have the three-dimensional view of the geometry. Another thing we can do is to look at the design screen, and we can see the wireframe of the geometry. The next step is to set up the boundary conditions. So we look at the CFD solver, set up CFD solver. We set the number of cells here about 1 million, and we set the initial X, Y, and Z divisions and the near body cells to split. The next step is to look at the boundary. Because we are looking at the mirror image, we click the ground effect mirror image option, click apply mirror image at minimum Y. Then in the dimensions tab, we set the minimum Y to 0. This would allow the lower boundary to coincide with this plane of symmetry. And then we double check the CFD model, which is the RAND, Reynolds Average Navier-Stokes, K epsilon, and then click OK. Now we look at the geometry again, and we see that we have a mirror image along the plane of symmetry. With the geometry setup and the solver setup, we can finally run the CFD. We go to the CFD solver menu and click the options to generate grid and solve the flow. After about 4,000 iterations, we see the pressure displayed on the right side of the aircraft. On the left side, we see just the plane geometry. Going further, we can take slices of the pressure coefficient across stations on the wing. And here we see stations at y equals 3, 4, and 5 meters. The method used here can be applied to a number of different problems. For more information, visit hanleyinnovations.com. Until next time, thanks for watching.